Okay. All right. So it looks like we are up. Yeah, we're ready to go. So hello, everyone. Welcome. And so basically, today, really, my intention was just to make this a day where we could ask questions about the project that's due Sunday, and we could just kind of engage and chat, and yeah, just kind of go through it because I know Common Lisp can be kind of a lot. So, like, happy to kind of go over either principles of Common Lisp or programming implementations or questions you have about the assignment specifically. I'm not trying to give full solutions, obviously, but to the degree that I think is reasonable, kind of going through and like explaining concepts or really understanding or helping out in that kind of capacity. So, okay, yeah. So we already have a question in the in the YouTube chat, so we'll get started there. And if anyone in person has any questions, we'll follow up. But the first question that we have is about macros, right? So the question really is about defining macros in Common Lisp. So rather than talking about this macro specifically, right, we will build just a general macro and kind of go with it. So kind of where I want to start with this is I'm going to, well, I already have one up. That's very convenient for me. I'm going to pull up, let me save this just so I know it's as Lisp code. Whoops. Come on. Cool, let's make that a lot bigger. And then let me just pull up my source. Okay, so, right, basically the question is like, how do we build macros? What is the, like, how do macros work? Kind of what is their purpose? So, kind of, I think the way I want to do this is I kind of want to focus and kind of pull back to the demo that we had in a lecture a couple of days ago, right? So if we recall a lecture from the macros lecture, right, D17, just going to unceremoniously open up on the screen I'm showing, then what we can do is we can take a look at that function that we build there. And I really like that one because I think it's a nice compact example that can show us some of the syntax building without getting too in the weeds. So let's kind of start building it, right? So basically, when we make a macro, what we're functionally doing is we are defining a new set of syntax that is going to be implemented when the program is executed and run. So for this little example, right, kind of what I want to do is I'm going to build this test expression macro that we saw in class. So I know it's the same example, but I think building it out is going to help kind of explain because we can kind of show how you build it, tweak it, and it's not just this is done, looky here. So basically, I kind of want to start with, so I think kind of the main thing is let's start just by kind of, maybe I don't want to do test expression. Oh, that. Okay. So let's go with test expression then. So basically, let's start by building this macro and kind of describing how this macro is going to work and behave. So what I kind of want to first do is explain what it is that we're building and why it is that we need a macro and we can't have a function. So what I want to build here is a macro test.exp that will take in a single expression and it will return two parts. It'll return the unevaluated expression and it will print the evaluated expression itself. Right? So that is what we're trying to create here with this macro. We are trying to create an operation which can produce both a printout of the unevaluated function and the evaluated function. Print. So it's going to return a string, so apologies for that. So basically, what I want to start with is explain why we can't do this in a function, right? So if I did something like defun, right, and I wanted to call this, and here's my issue, right? I have a single parameter called x, right? Now, the problem is like, you know, I can do print x, right, print out the value of x. The problem is that when I execute this top level line of code here, the underlying issue is that if we pass plus 3.5 in as a method, or excuse me, if we just pass that in as an argument to the parameter x, then it's going to evaluate plus 3.5. Right? That's the underlying issue here. That the parameter to the, so that the argument plus 3.5 getting passed to parameter x here, when we call test exp, it's going to evaluate plus 3.5. So that the value of x when we run test expression, it's not going to be plus 3.5, the s expression, it's going to be 8, the evaluated result of the s expression. So that's the underlying reason why you can't use a function to get the behavior in the comment on the right there, right? Because when we actually run this at runtime, plus 3.5 evaluates to 8 before actually calling test exp. So the value of parameter x in that function is going to be 8 rather than just an s expression. So with that being said, the reason that we have the macro option here is that macros are evaluated before runtime, right? Macros are evaluated at macro expansion time, right? So while we're doing a translation of the language, we convert all of our macro calls into the language that into the macro's definition. So let's see a way we can build this into a macro. So for a macro, we can do something like def macro test expression, and then we'll give it a parameter. Let's call it form. Okay. So now this is a def macro. It looks very similar to a function, right? And in fact, we really haven't done anything different yet. And even more so, right, we could do something like this. Now this won't work the way we expect it to. We leave it up here for that reason. So if we write something like this, print form, the issue here is that this function print is going to be executed at macro expansion time. So the body of the macro is executed at macro expansion time, not runtime, meaning that we don't have the value of form when we call the print function. Yeah. In fact, I don't actually think, I think it would get unhappy with us, right? We can try it actually right now. I'm not really sure what would happen, but I think the compiler, the interpreter, is not going to enjoy this, right? Because when it goes to expand the macro, it's going to try and execute code that really requires, oh God, hang on. Let me get rid of all my other terminal windows that I don't need right now. Right, so if I open up an SBCL window and I paste in our macro, right, and then I call that macro, oh, no, it does both. Oh, wait, yeah, no, cool. So basically, right, we see here it gets two versions, right? So we see how we get the plus 3.5 on the top and the 8 on the bottom. This is a weird result because it's a REPEL environment. So basically what's happening is that it prints the plus 3.5 at macro expansion time. and it prints the 8 after we've evaluated the result. Okay? So if I'm trying to build a macro where I actually have some content inside of here that gets printed later, then what I do is I backquote this and I comment out the form. So now if we do something like this, this should just print out 8. So if we redefine this, and then we call test expression again, we get 2 8s here, okay? So basically the difference here is simply this backquote and comma. So basically without the backquote and without the comma, what ends up happening is that at macro expansion time, so before runtime, before we have values, it takes the S expression for form and prints it out. It doesn't evaluate the S expression, right? Because at macro expansion time, we're not evaluating things. We're just fleshing out our macros, right? We're simply substituting test expression with the body of def macro. And the body of def macro executes a single function called print. Right? So that's what the body of def macro is going to be at macro expansion time. And so that is why it evaluates to +3.5 at macro expansion time. But when we actually execute the macro, it actually spits out an 8. So if we want this consistent, right, then the way we achieve that is by preventing the execution of the print until runtime, but allowing the form parameter to be evaluated at macro expansion time. So basically, what will end up happening in terms of the runtime is that we'll start with test exp 3+5, and then at macro expansion time, that will get converted into print +3.5, right? And then at runtime, this gets evaluated to print 8. And then 8 is printed to the console, okay? So basically, here we have, it's not how you spell expansion, I'm gonna just ignore that. Oh, you know what? So this is the macro call, macro expansion time, runtime, execution. So that is kind of the breakdown of how these macros evaluate, right? We have the actual call to the macro, and then at macro expansion time, we evaluate the body of the macro, not necessarily evaluating any of the given parameters, but rather just evaluating the body. And if we tell that body just to print out the parameter, it'll just print out the S expression it was given. If we tell that body to halt execution by using a backquote, but rather just evaluate the parameter form, then it substitutes out the parameter for the S expression itself, and then we have, after macro expansion time, the test exp call replaced with a print +3.5 call. And then at runtime, we actually execute the +3.5, and that gets us print 8, and then we print out the 8, and we get 8 as our final result. Okay? And so we can kind of continue to tweak that here. So I want to build this. So trying to think of something that's not too convoluted off the top of my head, because I do kind of want to, I know macros are probably one of the hardest parts of this assignment, so I do kind of want to add a little bit more juice here. I also don't want to go try and do something I'm not going to be able to do. So let's see. Okay. So having macro expansion time, basically, I think if I flesh out with a little bit more syntax, that'll be helpful. So if I have something like, let's say, it's not a great example, right? But let's say we have, I hate when it does that. We have an if special operator, right? And if we recall from the if special operator, then that means we basically have 3 branches, right? We have a condition, we have a true branch, we have a false branch, right? So if I have something like macro expansion time, I can basically abstract away constructs that are otherwise pre-built, right? So if I come into my demo, oh, that's better. I'm like, I knew I had a better one in here. Let's do the when macro, because that makes a lot more sense. So here, this is the one I want to work with. I knew I had a good example here somewhere. So basically here I'm making my when macro, right? And so the point of this when macro is to abstract away a condition. The condition here is the if prog n set of statements, right? So if I want to make a function, right, where it has some condition and some body of code to be executed when that condition is true, right, we would need to write it out a little bit more manually here, right? Provided we have our function call, we would need to do if, right? And then we would have to evaluate some condition, which would have to be evaluated like as an S expression. So write if condition, and then we would have to type out prog n, and then all of our actual S expressions here, right? So this is not really an example, but so I basically could have something like this, right? Whereas if two is less than 3, pretend these are variables, makes it a little bit more fun. But if this condition is true, then we have this being our true branch, and then maybe just nil as our false branch, right? So if the condition is true, execute multiple S expressions, else do nothing, right? Now, if we wanted to write this out as a function, we just need to write it out manually for each and every function, right? Whereas with macro expansion, we have the ability to make a macro. So what happens here is now when takes in a condition and a body of statements to execute when that condition is true. And rather than having to write out this if, prog, and set of statements each and every time we execute something, we can simply call the when macro. And so let's take a look at an example of this really quick here. So we can do something like when 3 equals 3, again, I'm being a little boring here, print hello world. So we do when 3 equals 3, and then we print hello world. Now let's take a look at what this might actually look like. So if this is our macro call, right? Then if we want to come down here, right, and we do expansion time, how this macro is going to expand is it's going to expand into this, right? So we see up here that we have a back quote here. So that means everything in this S expression is not going to be evaluated. So at expansion time, our macro call to when turns into an if statement, okay? And then when we see this comma condition, it means we take the value of the condition parameter, which in this case is equals 3, 3, and we evaluate the actual variable. Evaluating a variable just gets you its value. So if the value of the condition variable is a S expression, then it replaces the condition variable here with the S expression equals 3, 3. And then we come down here, we have prog n, and then we have a comma at body. So this takes the list and it splices it in to prog n. So here it would end up evaluating to hello world. And so this is what it's going to look like at expansion time, right? And we're not abstracting away that much in the while, and that's kind of the thing about macros is that their main potential really comes from reducing very complex structures, right? Taking very complex syntactic structures and reducing them down to very simple macro calls. Problem with that is you need to define very complex syntactic structure in the macro to really get that justification. And we don't really want to overwhelm and be like, here's this really messy, ugly looking chunk of common Lisp syntax that we're going to abstract away. So I'm trying to kind of show the benefits without overwhelming by having too much complexity in the macro itself. And I'm hoping that I'm writing that knife's edge without just kind of sounding redundant. So when we come into expansion time, this is what it's going to look like. And then when we actually go to runtime, right, we start executing these statements, right? So at runtime, and it's not as clean as down here, but at runtime we might evaluate some of the inners of this, right? So we'll do something like if t, right, because 3 equals 3 is true, right? And then we would execute all of these statements. Right? And so that would be something that happens at runtime, and then just the output here. Both, like it's the same. Like this is at runtime, so this is being executed. No, so the only thing that goes into SPLC is this macro call. All of this, the expansion time and the runtime, the output, this is all happening behind the scenes. And then the output of this is just going to be, right, just hello world. And so that's how something like def macro works, right? We have this all kind of defined. It takes in S expressions as its parameters, and at macro expansion time, it basically plugs in its parameters into the syntax defined in the macro body. So it goes from something like this to something like this, and then it actually executes at runtime and then produces an output. Okay. Do I have? Yes, you could absolutely start having multiple branches. You could flesh this out a lot more. So what I really could do here is say it's maybe not the best example here, but just to kind of show that, like, say there is an entire slew of things that are constant if a false value is approached, right? We could theoretically have a macro where for any given input, if it's true, we execute arbitrary statements, but if it's false, we execute the same statements each and every time. It's kind of a weird condition. I don't really know why that would come up, but that might happen, right? We have just a position where if a condition is true, execute custom code. If a condition is false, always execute the same thing, right? It might be like print to a log if false, right? Print log failure. And I don't know, we can imagine that there's a whole slew of statements that need to get executed on failure. And the nice thing here about this macro expansion is that this is still the call, right? And it's just that on macro expansion time, we just now have a false branch. Yeah, line 8 would stay unchanged, right? We would just call this would get evaluated to this, and you'd have this here, and it would still output hello world in this case. But if I gave it, say, a different value, and that's what it evaluates to, and this evaluates to nil, then our output would instead be log failure, even though log failure isn't actually a given parameter in the when macro. So I mean, like, if it was less than, well, it kind of all depends on the if statement, right? Because the if statement is just a true or false branch, right? So it depends on our conditional. If we wanted a three-way conditional, then we would, well, so the nice thing, and I'm going to actually need to not screw this up. True. So if we wanted to do if-else-if logic, right, then the way we have to do if-else-if logic is nesting if statements, right? So just to answer a quick question in the chat, could you have helper function / helper macros for this? Possibly. I'm not going to outright prohibit it, but typically you don't really want, for the assignment, for assignment 6, you don't really need helper macros. I don't think those are particularly helpful. I think those are going to take up more time than they're going to save you. If you have something that works, I don't want to say you have to scrap it, but just letting y'all know, I personally find helper macros to not be super helpful, and you don't need any helper functions to do any of the functions. If you have some, that's okay. Just remember the constraints of the program in the Project 6 manual. You can't have any def vars anywhere. You can only have defugs. So if we wanted to make this a like if else condition, kind of the thing I would say is, how do we want to do this? So what we could do gets dangerously close to the actual project, but if we wanted to do something like this, because I'm just thinking we need a second condition to test, right? So you need an if and an else if and an else. I'm trying to think of where I want to get that else if from. You know what I mean? So we have our condition. So instead of condition, actually, well, we might have to tweak this. So this is going to get a little ugly, but I'm going to hopefully salvage this. So I'm going to make another if statement here. Well, that's what I'm doing on line 6. So this is going to be another condition. So this is going to be true. This is going to be else if. And then this is going to be true. And then that's going to be false. So basically, here we're having an if-else-if condition. And what I might do is, instead of having condition be a Boolean value, I might say condition is some kind of number, right? And so instead of saying if condition, I will say, actually, you know what? Let's say, just trying to see if this will make sense, right? So let's say if expression is less than value, execute the body of statements. Else if expression is greater than or equal to value. So else, you know what? No, I like this. So basically, here's what we've done, right? Because now we're taking in two things, an expression, which is an S expression, and a value, which is just a single numeric value. We're going to have to unquote these. But so basically what's going to happen here is that when we execute this macro now, right, this expression will evaluate to the S expression given, this value will evaluate to the value given, and that will be the macro. So if the expression is evaluates to a value less than the value, we execute these statements. Else, if the expression is greater than the value, we execute these statements, which are currently undefined. and then else now actually what I kind of want to do here, just to kind of, I'm really going to hope this works. It should, but fingers crossed. What I think I might do is I might swap these out really quick. So basically what we've created here is we have created a little doubly nested if statement, which gives us if, else logic. So we are given an expression and a value, and if the expression evaluates to something less than the value, we print out that the expression was less. Else if the expression evaluates to something greater than the value, we print out expression more. Else, i.e. they're equivalent, we print out the given statements, okay? And because this is again, this can be multiple statements. Again, this is kind of a janky macro when you think of what it's doing. It's more just showing how this evaluates, right? And so now, let's come down here and let's once again show our macro call, right? So we have our macro call, except this time it's going to be an expression, an arithmetic expression, right? And then a value, which I'll call 7, and then some statements, right? Which in this case, just... say that again, please. Oh, ampersand rest argument. So actually, let me finish this and I'll explain it. So the ampersand rest body means that the parameters to the when macro, this S expression gets bound to this parameter, the 7 gets bound to the value, and the rest all get bundled up into a list and stored in the parameter body. So when we execute this statement, the value of body is going to be a list containing both of these S expressions. So body stores that. Okay, that's what the @rest parameter does. It takes these two S expressions, which is everything after these two parameters, and it combines it into a list, and then binds that list to the body parameter. Yes, exactly. So, so if this is what our macro call is, then let's see what it will look like when it expands. So this is going to kind of get a little messy because it's going to expand to all of this code, right? Except here, right, now we're going to get rid of this. I really hope I did this right. And so basically, we're going to replace out expression with the expression that was given. We're going to print out, we're going to replace value with the value that was given. We're going to do the same down here. And @body, or this thing, gets substituted out for that. So this is what our macro expands to. So now we really start to see the power of macros here. So I appreciate you asking for this kind of example, right? Because we see this entire if, else, if structure is defined in the macro, but when I want to make an actual call, it's still just a one-liner. Now at macro expansion time, this when call transforms into this code. None of this code has been executed yet. This is now source code to be executed at runtime. That's the beauty of macro expansion time. It takes simplistic definitions and expands them into complex bodies of code, but it's not running anything per se. It's now at runtime just going to execute this. So when we actually like do runtime, right, and I made these equivalent to each other. So runtime is basically going to evaluate plus 4, 3 to 7. 7 is not less than 7, so it comes down to this if statement, right? And now this is just evaluating standard common list code, right? 7 is not greater than 7, so it comes down to the false branch, does the prog n, and it prints is equal hello. Okay? Now, I'm going to do something dumb here. I'm going to see if I actually wrote that right. Yes. See, here's the thing. As much as I am confident that I know how to program in Common Lisp, doing a demo on the fly is always a risk, because there's always the chance you screw something up. But it actually works, which is something I'm very happy to see, right? So we execute that it is equal and hello. And it just prints out hello twice because that's results of the repel environment, right? The repel environment reads, evaluates, and then prints the evaluated value. And the print function both prints the given string and returns the given string. So that double print of hello is just the repel environment. It's not our macro. Whew. So I hope that kind of helps explain a little bit better. Yeah, no, syntax can be a lot. So, and also, let's try something here. I'm continuing to be bold here in my, I want to see if this works. So there's a function called macro expand, which will give in, and you'll see that it's quoted here, right? It's quoted. So when given an unevaluated macro call, it'll actually evaluate, or excuse me, expand the macro for us. So it's called macro expand. And yeah, it'll basically, look at that. The match is actually pretty much on the money. I'm allowed to be proud of myself of not screwing that up. So, but yeah, so you could actually do this thing I did manually, kind of in my head on paper, and have SBCL do it for you, which I think is kind of nice. So, didn't intend to spend 40 minutes talking about macros, but I hope it was at least illustrative. Willing to talk about other subjects in the 10 minutes that we have. I do want to quickly answer a question, though. Someone asked if you can use looping macros for the assignment. The answer is no. Spare yourself. I'm just going to tell y'all, if you get a looping macro working, I'm not going out of my way to take off points, but I cannot tell you how many semesters I have given out a Common Lisp project, and I've seen people use looping macros thinking they'll be easier, and they come to me on the deadline day and be like, why does my code not work at all? And it's because the looping macro has betrayed them, and it is not doing anything remotely like what they think it is doing, and I'm just like, you have to scrap this. And that's not a fun conversation to have or a fun conversation to be on the receiving end of. So if you have working code, I'm not going to knock points off, but if you haven't already developed your program, I really highly advise not using the looping macros. That's my hot take. So you had a question. So if you look on the SBCL documentation, oh, by the way, the question was if we're looking at just like arbitrary Common Lisp functions, how do we know if it's a prohibitive function, right? Like it's derivative of setq or otherwise destructive. Just look at the documentation. If you can't find anything on the documentation page that says very clearly like destructive function, implement setq or something along those lines, you feel free to use it and be safe with it. Because I'll be honest, that's my reference, right? I am not some Common Lisp guru. I do not program in Common Lisp in my free time. I learned it for this course, and so the documentation is my main resource. So if the documentation page isn't making clear references to it being destructive, or it being derivative of set q, you'll be fine. Yeah, everything's fair game as long as it's not destructive. And the way I kind of say that is there are a lot of, and I kind of said this before, the point of learning Common Lisp is to learn functional programming, and there are a good number of non-functional concepts jammed in there in a desperate plea for people to use the language. Like, hey, it doesn't all have to be functional, come to our side. But we're stuck with the functional for the sake of being functional, so I'm prohibiting that non-functional stuff. But other than that, yeah, fair game, whatever you feel, find, and think is the best. I'm all about. So, yeah. Yes. So, hang on. And this is posted, by the way. But if I go into assignment 6, there is assignment 6 examples. And so again, this is on Canvas, so everyone can look at this. And this is basically just showing us some examples here. Probably should have saved it as a .list file and not a txt file, considering I commented everything, and now I don't get code highlighting, but that's whatever. So basically, this is showing us the potential function calls and the potential outputs of those calls, right? So, for example, clean takes in a func, and it takes in a list of data here, 2, 3, and this is character f, 4, 5, hello, and it returns 2, 3, 4, 5. Okay? So it is iterating over this list, and it's basically applying a func similar to a map operation, similar, in the idea that a func will take in a single parameter, i.e. the current element of the list given, and if that function returns true for its input, if it returns true, then that means that element is retained and kept in the output list. And if this function returns false, like say maybe this one does, then it does not get put into the output list. Does that make sense? Does that answer your question? So you're not comparing it to anything. You're just putting it in this function. And that function's arbitrary. All we know about that function is it takes in a parameter and it returns true or false. What it's comparing to is unknown. Well, you don't, because, well, it depends. What is this type to? Like, oh, I think this isn't very good, but like, look at his type. Right, a common list function named isType, which takes a single parameter named dataType. isType will return an anonymous function, which takes a single parameter and returns true if that parameter's dataType is the dataType specified in dataType. So the way isType works is it creates an anonymous function, which takes in a single value, and if that value is the dataType that was given, it returns true. If it's not that dataType, it returns false. No, I know. Because if we take a look at number 7, you have a func, which takes in a single parameter and then returns true or false. And it seems to be cleaning out everything that isn't a number. There's a correlation here. A func can be any arbitrary function. You have no way to define it. But the function, if you want to test this, and you need a function to get clean, why not give it the results of this type? Because we're comparing it to anything. We're basically, a func is its own function defined, and however a func decides to execute is whether or not something is in a list. We could have a func taking a value, and if it's not numeric, it is false, and if it is numeric, we compare it against another value. So it only keeps numbers less than 10. A func could take in and only accept strings that are a certain length long. Anything that is not a string or less than that length gets thrown out. A func is completely arbitrary. We don't really know the innards of how it works. Now, these examples here very kind of seem like they're stripping out everything that's not a number and not doing anything more. And again, that's because you define a function with that behavior in question 5. But what a func actually does is not relevant to implementing clean. The only part of a func that's relevant to implementing clean is the knowledge that it takes in a parameter and returns true or false. That is the only real thing relevant to a func. All that we care about in defining clean is that it takes in a parameter and it returns a Boolean. And if it returns a true Boolean, then we keep it in our list. If it returns a false Boolean, we take it out. We don't actually need to know and or care what metric it's using to determine truthiness or falsiness. It helps when we're trying to debug our code if we know what a func is doing. But in terms of how we would implement clean, it doesn't matter. Yeah. No, go back and kind of let that, because like the connection between 5 and 7 is one of those big brain things I decided to put in there because I felt like, I don't know. But yeah, no, that is kind of the principle of clean. Also, by the way, just like a hint, the sublist cleaning is probably one of the hardest parts. But like, if you have, here's my advice to everybody. Ignore sublist cleaning. Just build clean that works on a single list. Because if you have a clean function that works on a single list, implementing the sublist cleaning is really not that hard. It should just be a recursive call. And by the way, from isType, right, we know that isType is a function that allows you to get basically you have to compare the data type of a value. So we know that you can compare the data type of a value to a data type, right? We can discover what the data type of a value is. Hint, hint, lists are their own data type. That'll help you a little bit with clean. So that's my time. Any last minute questions, I'll be happy to answer. The test file itself doesn't actually run. It's just examples to kind of show you, given this input, what the output should be. Just so you kind of don't just have my wall of text, but you also have some before and after photos, so you kind of have some idea of what these things are supposed to output. Okay. Any other questions? Oh, wait. Sorry, I got confused. No, assignment 6 test.list does run. I'll do that while we're cleaning up. If there's any other questions, I'll be happy to take them. Yes, I know, timer, thank you. So let me just, so what I'm doing here is I'm changing my directory to where I have the tests. And we can see here that I have assignment 6 list and assignment 6 list test in the same file. Wait, is this the right one? Yes. And so if I want to run this, I'll just open up SVCL, and I'll do load, and I'll simply just take the name of the function, and I'll run it. Oh. And this is what it looks like locally. So you need to make sure that A, your terminal is in the directory of the tests, so you don't have to put in the full file path to load. You can just put in the name of the file. And then B, make sure that the actual file, the test file and your source code are in the same directory. Because if we actually look at the tests, we will see that the first thing they do is load assignment6.list. So also, if your file's not named the right thing, it's not going to work. You've got to make sure it's got that capital A, that .list file extension. I apologize to everyone on Windows. File extensions kind of suck, because of course they do. It's Microsoft. So, but you got to make sure it's got that exact file name, or else it's not going to see your code. But yeah, so you can run these tests. Sorry, I misunderstood the question. I apologize. But yeah, you can build these tests directly, and this is what it looks like. when your professor's already built the solution set. But ultimately, this is the goal for all of you to see as well. To see everything all passed. Oh, and by the way, I do my best to make the output messages somewhat helpful, and I did my best, I tried to do my best to actually make these good tests. I hope you all are appreciative. This is 850 lines of fucking commonless test cases that I wrote from scratch. A while. This is multiple semesters of iterative processing, by the way. This is something I finally got happy with, but like, oof. Some of these, there's a lot of let blocks and a lot of, I had to do a lot of fancy stuff so it didn't crash the program when something went wrong. Yeah. But anyway, thanks for all for coming. I know I'm way over time and I'm just rambling a little bit. If you have any questions, feel free to shoot me a DM on Discord. And like, I know I said it's due Sunday, but I'm not grading it Sunday night. I'm not going to grade it till Monday night at the latest, or at the earliest. So like, if it comes in Monday, that's okay with me. Enjoy spooky season. No. Probably going to get high in my basement and hope no kids knock on my door. Maybe a little too real, but I had my Halloween parties like last week. I want to go out, but all my friends are lame. No, you're not. I love you guys. See you, everyone.